we thought what we would do is to give you a sense of a range of projects we've done in information visualization, ranging from things that had to do with some of our scientific research, all the way to the more artistic pieces that we've been doing lately. And so let's get the show started. So this is good. We're going to try to share the mic here. So we're going to start with one of our latest pieces, which is called the Web Sphere. And the idea here is to look at Google. So let me just do a little thing. Okay, so you've probably noticed that if you go to Google these days and you start typing something like Boston, Google completes stuff for you, right? It suggests things. So this is called Google Suggest. And basically what it's doing, it's suggesting to you some of the most popular searches that come after the word or the phrase that you have typed into the engine. Which makes all sense, right? It's great because it's convenient because it auto-completes, and that's the whole intent behind Google Suggest. Now, one thing that might not be as intuitive is that people are actually going to Google and asking questions, and we can see what questions people are asking. So if I just go here and I type, why? It's always fun to take a minute to take this in, and you know, why not try to visualize some of these suggestions and in fact start comparing things. So we created this tool called the Web Sphere, and the interesting thing is that here, not only can you visualize one set of suggestions, you can compare that against a second set. So if I come to the tool and I say, why doesn't he, why doesn't he call me, why doesn't he like me, why doesn't he ask me out, and so forth. But I can compare that against why doesn't she. And I can see right away the things that we share in common, versus the thing where men and women are potentially different. As you're probably understanding, what we're doing here is we're also mapping the frequency to the size of the font and the thickness of the arrow. So, whenever you have a bigger font, it means that those are more popular searches on the engine.
We're going to go through a couple of examples here, and these differences in gender are actually pretty revealing. Let's try another one. How about is my daughter versus is my son? Insecurity is a better word.
To continue with the family theme, you obviously have to do things like, is my wife versus is my husband. And you see that very quickly goes from being really funny to quite depressing, a depressing portrait of marriage.
So let's wipe that depression away. I want names of 2 celebrities shouted out from the audience, please.
Prince.
Prince.
Cameron Diaz.
Okay, first Prince. Question. And what was the second one?
Prince William.
Cameron Diaz. Cameron Diaz. Okay, there's Cameron Diaz. And so, I want to know, are they married? You might have a chance.
Can you imagine how much time you can spend? Interesting things here. You can also ask more philosophical questions. So how to be, and we can find out what people are trying to be. But then you can pair that up with how to pretend to be. And you can see where we intersect, thankfully on a positive note, but it's interesting that people are wanting to pretend to be all sorts of different kinds of things.
That's kind of a metaphysical one. So let's go simply to how to versus how not to.
Okay, and because no demo is complete without politics, let's turn to our Democrats.
The Republicans didn't want you to see it.
Versus our Republicans. You can get a sense of the confusion.
Yeah, clearly it's a divided country, but let's end with something that's not a question. Republicans are versus Democrats are. And you can see
so this is online and available. If you want to spend time playing with it, we suggest check out webs here. So now, yes, let's go back to our presentation. We thought one of the things that would be interesting to do was to show you some of our earlier work and how we got interested in visualizing things like the collective and the social collective. And we started from one of the major collective websites available, which is Wikipedia. And what we're going to look at here is a project we did back in 2005. When we were interested in how we could visualize what a person's activities on Wikipedia look like over time. So imagine you have one editor on Wikipedia, and you're following, and maybe it's a very, very active person. How do you visualize what this person is doing? The data looks like this. It's a log of all the pages, all the places they've been on Wikipedia, what they touched on each page. Maybe it's articles, but as some of you might know, Wikipedia is a lot more than just the articles we read, right? There are all sorts of different kinds of pages. There are policy pages, there are images pages, all sorts of different kinds of pages that people could be touching at any given point. So we decided to look at visualize Wikipedia admins. And the thing is that, they get access to a bunch of different kinds of functions. They can delete pages, they can protect pages. Their edits per person tends to be really, really high. So, we had someone in our data set who had over 100,000 edits, and which turned out to be what? For the period of time we were looking at, one edit every 10 minutes, yeah. 24 hours a day for years.
So appreciate that next time you're on Wikipedia.
Exactly. So how do you visualize this, right? The problem is that you have tons of little edits. And how do you see patterns when people are touching things that are so incredibly different, such as articles? The articles themselves can be about a ton of different kinds of subjects, and then there are all the other namespaces, all the other spaces within Wikipedia. So our solution was to turn text into color, okay? What we did is we looked at the first few letters of the title of the article a person was touching. Okay, so if the article was called Brazil, we were looking at B-A-R, okay? And we would assign a hue to the first letter, the brightness to the second letter, and the saturation to the third letter. So what we did was basically to map the alphabet to the spectrum of colors, okay? So any words that start with A tend to be in the reddish zone, because that's the beginning of the rainbow, right? And then all the way to the end of the alphabet, so words that start with W or Z would look sort of purplish. And any numbers would look gray, because we're not assigning colors, hues to those. All right, so let's look at chromogram. So let me just do something very quickly here. So this is what chromogram looks like, and this is one person's activity over time. This is basically a timeline here. It starts in October 4th, 2004. Each one of these rows is a day's worth of activity. So as I'm going down here, I'm going down on days. You can see that this day here was much more active than the other days. Each one of these colored little rectangles is one edit that this person made. So this was to sparkling wine, this was to cork, this was to pomace, and so forth, okay? As I mouse over, I can see every single article that they touched. But this person has been touching Wikipedia for a long time, so I actually have this scroll bar here on the right that I can pull, and I can see some of the burstiness. So for instance, they were really, really active in this particular period. So let's look at what they were looking at. Again, you know, they are looking at wine, sparkling wine, cava, Zinfandel, Greek wines, French wine reason. You get the sense, right? There's a theme going on here. They're talking about wines. They're editing wines. But then something happens. They get done with it, and then what are they coming back to here? Breweries, brewery. They're done with wine, and they're starting on beer. Okay, so that's their little project. They are going for Belgian beer and so forth. And all sorts of different beers. So very methodical, giving themselves a little projects. I'm going to do wine, and then I'm going to do beer, and so forth. Great. Now, if I want to visualize this in a more maybe effective manner, so I don't have as many white spaces, I can just go from a timeline to a block view. And what I'm doing is I'm just getting rid of the white spaces, and now it reads like a book from left to right and down. Okay, so the oldest edit is at the top left, and the most recent edit is at the bottom right. Okay, and then we can start looking at some other people. So, for instance, this one person who didn't even bother to register, it's just an IP address, looks very, very different. They have huge blocks of edits to the same article, which is November. So they're going November 23rd, 23rd, 24th. November 24th, and then I go down, they're on 28th, 28th. So they're doing the months, right? Here, it's December. They're doing December 6th, all the way, I'm going to go to the 7th. Yeah. So they're going over in time on Wikipedia. Wikipedia obviously has a page for every single day of the year, and a page for every single year. And what exactly are they doing? And then, look, they're switching to years, 1943, 1945, 1950. If I switch my visualization from looking at the title of the articles to the actual comment that this person has left, I see a very interesting pattern, like these blocks that are repeating. And when I mouse over them, I can see it's the second line. It says births. So they're putting all these births on December 3rd. And then they're putting all the deaths on December 3rd, and so forth. So basically, they're keeping the obituary and the birth certificates on Wikipedia. And that's the little project that they're doing. So what this visualization is allowing us to do is to pick up these very methodical projects that people give themselves and the very systematic ways in which they go about editing the encyclopedia.
So let's talk about some other things you might see. One thing that was surprising to us is we started looking through these, and the truth is it becomes very, very fun. You can you see different patterns in each example, and then we came across one that looked like this. So this is someone named Seth Illis, and let me just scroll through this. We're looking at a total of 47,217 edits. So one thing you can do is just sort of appreciate, you know, the scale of this. But there's something else that really pops out at you here, and that's the rainbows. That you see that the colors are really not random, even though they're going from article to article. There's, you know, the long sort of purple area here. There's green. There's yellow. There's red. And why are we seeing that? Well, it's because of the encoding scheme where we're mapping the first letter to the hue. And then in turn, this person, if you look carefully, is actually going through a whole bunch of things, alternately in alphabetical order and occasionally reverse alphabetical order. And what happens, because they're going through things in order, is you get these beautiful rainbow patterns. They're actually doing stuff that is sort of much more complicated. You can see they're really switching between a bunch of tasks, and that comes out here as well. But what you see is that there's a clear alphabetical bias in what they're doing. So we got very interested in this, and it turns out that you can see this in a whole lot of examples. Here's someone who also has these very distinctive rainbows as well. And we're able to do a statistical scan of all the users and discovered that yes, it's very significant. A whole lot of people work in alphabetical order. And then we could do yet another statistical analysis and look at articles in Wikipedia overall. And you could ask, okay, if everyone's going through lists in alphabetical order, and these could be lists in various projects that people have put up on Wikipedia, their own to-do lists, is it possible that articles at the beginning of the alphabet actually get edited more? And the answer is yes, that there's a statistically significant relationship between where something is in the alphabet and how often it gets edited. So, for the Wattenbergs and the Viégases of the world, that's unfortunate, but for people whose names begin with A, it actually works out very well.
And our favorite user here is someone called Pearl, who really, seem to have selected something here I didn't want to select. So let's see. Oh, yes, thank you. Thank you. All right. And let me change this to title. So this is our favorite user, called Pearl. And check this out. This one very, very long rainbow, and interspersed with much shorter rainbows. And then again, to the longer rainbow, right? But this is all about rainbows all over. So basically what's going on here, this user is actually a bot. It's a robot that goes around Wikipedia doing stub sorting and doing categorizations of different articles. And obviously, one of the mechanisms that it's going to use to go through, to decide which articles it goes through is exactly the lists of articles that Martin was talking about that are alphabetically ordered. So, something that was a visualization technique that seems quite arbitrary, right? Because it takes text and it sort of summarizes it into colors. So you're leaving a lot of meaning behind, right? Still enough of a projection that gives you meaningful patterns and that allowed us to find out things about the Wikipedia and about the dynamics of how people were editing it that was sort of surprising and new to us.
So we want to talk, oh yes.
Just a quick question. So I mean the mapping of letters to colors brings up all this interesting stuff, but there are hundreds of other mappings that could have brought up all kinds of other stuff that you missed and maybe are more interesting. How do you deal with that issue?
So this was quite a process for this specific project. We were working with this data set for 3 months and had all sorts of different techniques that we had applied to it. And finally, and we weren't getting anywhere. We weren't getting anywhere exciting with it. It wasn't until we decided to do this seemingly random technique projection that we decided, wow, we're actually getting some interesting patterns here that we weren't aware of before. And one of the reasons is because we decided with this technique that instead of aggregating data up and up and up and find that, and end at a very high level of aggregation, we were going to look at every single instance of edits that people were doing, which allowed us to get enough texture from the data and the visualization that gave us these rich patterns to look at. But you're completely right. There could be different ways of encoding the same visualization that could give you very different patterns. This is just one of the projections that you could use, and it was useful to us.
Yeah, I mean, it's a very interesting point because you can imagine mapping color to parts of a thesaurus or something with some sort of semantics behind it. those approaches are interesting, and they can often yield good results, but I think one of the themes of this talk actually is the value of almost superficial lexical analysis for certain things. And in fact, the next two visualizations we show will have that aspect as well. Before we show you those visualizations, I want to talk a little bit about, very quickly, about a system called Many Eyes, which we created while at IBM. The idea behind this site is it's a website that anyone can go to. You can, if you're online, you can go to it now. It's many-eyes.com. And it's like Flickr or YouTube for data, that you can upload your own data to it, and then you can apply any one of more than a dozen visualization techniques to actually see that data in different ways. And the whole thing is in public. Anything you upload is in public. You can see what other people are uploading. You can comment on their visualizations and so forth. It's been an incredibly useful research lab for this sort of technique in general. So the next couple of visualizations we show are going to be shown sort of in situ on that site. The first one is called the word tree, and let me explain how it works. So this is aimed at visualizing documents, and it's visualizing them by looking at repetition again, just plain repetition. And the idea is you take some sort of document, so imagine we're looking at the script for Romeo and Juliet, and we also take a search term as a starting point. So in this case, the search term is if love. When we do that search, we'll get a bunch of results. So, if love be rough with you, be rough with love. If love be blind, love cannot hit the mark, etc. That's very simple kind of keyword and context results. And we just arrange them in a tree. Okay. So you computer scientists could think of this as a suffix tree, but if you're not a computer scientist, don't worry about it. It's actually very intuitive. You're just showing in this tree that basically everything starts out with B after if love, and then there's another branch where if love be blind actually gets mentioned twice, and so forth. So what does this look like with real data? Let's go to Many Eyes and take a look. Okay, so a classic repetitive piece of text is Martin Luther King's famous "I Have a Dream" speech. And so let's just see what we get. If I type in I immediately see a main branch of I Have a Dream. There's a bunch of other I stuff here. If I want to, I can focus in just on that. I can click and see, okay, yes, I have a dream that one day, that particular part of the peroration, that's mentioned a whole lot. There's other sections to it. And you sort of get a sense of the sort of complicated structure behind this very beautiful speech just by clicking through. Now let's go from that to something a little bit larger. Let's take the entire King James Bible. So this is something that I believe is roughly 1 million tokens, where a token is either word or punctuation. And let's just take a look at what's in there. We can say, and God, we can say, said, we can see what God is saying. A lot of God said unto him, less God said unto her. That's interesting. God is speaking unto various people. I can look for familiar phrases in the beginning, and I can sort of see this all, happens in real time. There's one very familiar phrase, but, a lot of things began, a lot of rains and so forth. I can play with this in other ways. I could put a question mark, for example, and look at the end and instantly get a list of all the questions in the Bible. I can see that questions tend to end in "the." I can see "with be." I can start to see patterns. And it becomes a way of sifting through this very large document very quickly, turning anything, even things without links, into something that's a kind of hypertext. Let me finish with one sort of amusing example. So on Many Eyes, as we said, anyone can upload any data they're interested in. And we get all sorts of data there. We had one user who was very interested in personals ads. We didn't talk to the user, we only could observe what they were uploading. And one of their sets of ads was from women and contained some words you might be surprised at seeing. We have I, let's put in that, and we can see this turned out to be the list of ads that contained the phrase, I am married. And we can explore this, and you can sort of see the differences in philosophy. I'm married and, I'm married but. And it becomes a way of looking into this set of documents, and I think more than a word cloud, because you can see this context, it really gives you a sense of what's deep inside.
So to continue on the theme of repetition and text, we're going to talk a little bit about a second visualization technique for text. One of the nice things about text is that, when you read a novel, for instance, you end up with a whole network of concepts in your mind, right? There is maybe the whole network of characters in that book, and maybe there's a whole network of concepts that come from the book, or a network of places. And we wanted to get at some of that by creating some network visualization that would capture these different kinds of relationships that you end up with when you read a book. So we created this visualization called the PhraseNet. And the way it works is very simply this. You create a sort of expression. You have whatever word, you don't know, it's some word on the book. And then you decide what is the connecting word. In this case, it's and. And then you have whatever word comes after that. That's all you do. So all you're deciding is what's the connector. It could be and, it could be but, it could be no, it could be at, whatever word. And then you run a piece of text through that. So for instance, this is a piece from Jane Austen's Pride and Prejudice, right? So it's just a sentence, and we would have picked out from that sentence pride and impertinence, right? Then we transform that into a node and link diagram. So pride and impertinence become nodes. And then the little edge there is the and, okay? So the other thing we do on this visualization has to do with layouts. Whenever you have networks, and I'm sure most of you must have looked at networks, visualizations of social networks and so forth, you end up with a lot of things crossing, a whole lot of things crossing. And sometimes you don't need to have all of that crossing activity in view. In fact, what we're doing in this visualization is we're trying to simplify the graph in terms of the node equivalent. So for instance, whenever you have a structure like this, which we would call a star, it really just matters that A is connected to all of these things, right? But if you switch the order in which these nodes are connected to A, it really doesn't matter, right? They're sort of equivalent. So what we decide to do, instead of drawing every single one of these links, we just sort of pack them all up into a big list, and we connect that list to A, okay? So and then it ends up being something like this. And this way, we decrease the amount of clutter you have in the visualization. So this is what a PhraseNet looks like. This happens to be a visualization of, we got a data set from a professor named Franco Morelli, who is a professor of English in Stanford. And he was really interested in looking at titles of novels going all the way back to the 1600s. And so he was interested in patterns like X's Y, okay? So things that had to do with the possessive. And based on all the titles, there's hundreds of thousands of titles, you get this network. And you can see that, daughter is a big, big word there. So daughter tends to be, someone's possessions. But so are women. Women is also soldiers. So let's look at some of these interesting clusters. Wife and bride. So you can see that you have, the banker's wife, the ambassador's wife, the bachelor's wife. Or in terms of bride, you have the sailor's bride, the freebooter's bride, the bandit's bride, the pirate's bride. Isn't it interesting that just by doing this matching, we can see these clusters, very benign cluster around wife, very respectful banker, ambassador, officer, but around bride, it's, pirates and freebooters and sailors. And so isn't that an interesting insight to have? The other thing you can do is, let's look at a novel. Let's look at Pride and Prejudice. Just by doing the pattern X and Y, I have a bunch of very different, interesting clusters. So, for instance, I have the social network. I have the cluster of characters. So Elizabeth and Jane, Catherine and Jane, Bingley and Jane, and so forth. But I also have very different clusters that also fit this pattern. For instance, the cluster of vanity and pride, conceit and pride, folly and conceit, ignorance and folly, right? So you get the sense of the concepts that are sort of clustering around pride. If we take the same exact data, the same exact novel, and we change the pattern that we're using, and instead of using X and Y, we use something like X at Y, we get the network of places in the novel, just by changing that one little connector, okay? So what that does is that it buys you a lot of stuff for very cheap, right? You get this network of interesting concepts, and all you're doing is you're matching expressions. In fact, this is a family tree from the Bible. It's X beget Y. And just by doing that, we get this incredible circle with a really, really long tail. And you get these interesting little circular patterns, like between Johanan and Azariah. And you can see what's happening there is that someone's son is naming their own son after their father, right? So you get this generational circularity amongst the names. And then finally, you know, if you speak regex, you can get really sophisticated with the stuff and get to some of the alliterations on, this happens to be Leaves of Grass by Walt Whitman. And you can get things like, you know, the simple souls stand silent and splendidly, or silent stars shining under the sun. And again, these different sort of clusters that you get just by matching simple expressions.
So it's, you know, it turns out to be a very flexible technique. It's also a very left brain technique. So, you know, we took you deep into the heart of looking at text and creating networks with regular expressions. We're going to switch to some more right-brained material now and move a little bit towards the artistic side of things. And we want to talk to you a little bit about a project of ours called FleshMap, in which we explored various aspects of how the body is treated in various ways in society. So, ooh, should we talk about this, or what is our time?
How are we doing?
About 20 minutes left.
20 minutes left?
Should we talk about this, or?
Yes.
Yeah.
Yes.
All right, okay.
All right.
I'm sorry, I got your hopes up for the right brain thing, but
We're going to wait a little bit more.
we're going to wait a little bit. We're going to give you
others.
one last
You can
piece
go.
of repetition here. And talk about a project, this was sort of one of the last things we did at IBM, called Chimera. And the idea behind this was to take this repetition to sort of an extreme, where we've looked at repetition within documents and say, what if we look at repetition across documents? What do we see then? And if you think about it, a lot of collections of documents that you deal with actually have a whole lot of repetition in them. You know, one example would be anything legal. You know, we're all familiar with sort of legal boilerplate and how that piles up. So one set of examples we took is a set of terms of service. So here, you know, this is a typical terms of service document taken from the web. We took 1,000 of these, found for being the search. And then we put them all together and looked for where are there repeated bits, and then we highlighted them. So for example, in this particular terms of service on the left, we highlighted all the sentences that we found, or sections that we found in other documents. And you get this, and you realize, okay, there's very little that is unique here. So maybe that's not a huge surprise that legal contracts have boilerplate, but let's play with this a little bit. So one thing you can do is get a quantitative view. You can get a sort of boilerplate skyscraper, and you can see which sections are repeated the most just by stacking these up, and that can be kind of dramatic and interesting. we looked at our own, the many eyes terms of service from our own site. We're glad to see our lawyers actually seem to be very creative. They were, that's good. What else can you see? The few things they did take were sort of very boilerplate-ish. One thing that was interesting is we found this site, so Ning is actually a very well-known social network creation site. And when we looked at its terms of service, we found there was a whole lot of this particular purple color that was one particular other document from a site called IASG, where they seem to have pretty much taken the terms of service. I won't say they took it. It's hard to tell from the outside exactly what happened, if maybe there was some business relationship between these. But what we can say for certain is their terms of service were very, very close to Ning's. And in fact, often there'd be an entire paragraph where they just swapped out, IASG for Ning, which is very, very interesting. What else can you see? Well, one thing that's interesting is you can look at laws, okay? And we actually had a journalist named Chase Davis tip us off to this use case, where he said, right now, if you look at state legislation, what is, the poor people who make laws, like, you think of them as powerful, but in reality, they're actually really stressed out and overworked. You have to put yourself in the place of someone who's, in the state legislature, in most states, they don't even have any help. But they're really ambitious. They want to pass laws and get things done so they get reelected. And it turns out there's this sort of evil symbiosis that happens, where there are also a whole lot of corporations, interest groups, that actually have plenty of time and can get plenty of help and plenty of lawyers to draft laws and write laws. And they'll sort of bring what they call model legislation, meaning laws that they've drafted for their interests, to various lawmakers and say, go ahead, you can pass this as your own law. There's one organization called ALEC that's particularly notorious for this, for example. So the question is, if you have a tool that can spot repeated passages across all sorts of documents, can you see this in action? And it turns out you can. That we were given actually a fairly small set of sample data from just a few states for 1 year. And what we were able to find is exactly a law that had to do with gun control, or lack thereof, that was being passed in pretty much the same form in several different states. I think here we have Minnesota and Alaska with a surprising amount of repetition. It turns out that if you Google the phrases in this law, the distinctive phrases, you actually end up at a website called the Firearms Freedom Act website. And it's this sort of funny, like, open source legislation thing that they're all getting together and they're like, let's write these states' laws. And they have, suggest people write in saying, oh, let's see, we can tighten this here, we can tighten this there. And then they go out and try to pass this in various places. This is not one of the more secret ones, but it turns out that, not knowing it existed at all, it just pops out when you apply this kind of simple repetitive analysis. Okay. So with that, I think we have time that we can go through some of the art. We'll move on to the right brain side of things. So let's talk about lyrics. Let's talk about music. And let's consider, let's look at songs and just to ask, how do songs talk about the body? So we decided to look at this from the standpoint of data and gathered the lyrics to 10,000 songs, categorized into 11 genres. So that is all available on the internet. It's kind of amazing, what's out there. And then we came up in one big brainstorming session a list of 83 body part words. And it's really kind of amazing, given how few body parts there are, just how many words. And we said, let's just look across different genres how often these body parts are mentioned. So, it's pretty easy to write a program to get this data, and, you get a big set of output like this, and, folk songs, for example. Okay, the throat is mentioned in 1.64% of the songs in our sample. That in itself isn't very dramatic. You could try making a bar chart out of it. That's okay. It's still not super dramatic. But it doesn't really get across the idea of how these things are treating the body. You don't get any initial impression. So we realized that what we should do is make the body parts themselves part of the graph. And we created bubble charts where we, with the help of a very nice stock photography, we got all sorts of body parts, and we made them into little circles and sized the circles proportionally. And here you see folk music. It's a very nice, sweet, gentle genre in which you're looking at eyes and faces and lips and heads.
Why don't we see heart?
We only did external organs. I think a big bloody heart would have, given we're using photographic imagery, might not have had the effect we wanted. So that's folk music. Let's look at some others. Here are the blues. Actually, surprisingly similar to folk. And maybe the knees are bigger. I don't know what that is. But we can keep looking. How about heavy metal? Actually, the interesting thing about heavy metal is that you might imagine that it's incredibly crude, but at a macro scale, and it certainly does have more body part words than folk or blues, but it actually has, eyes are the biggest one. Those metal ballads are a big deal. Face, hands, all of that's there. It turned out that this is actually characteristic of pretty much every genre we looked at except for one, which was hip-hop. An entirely different outlier. It's hard to miss. And, in the end, you can kind of sum this all up, actually. With, diagram, you'll actually sort of see, there's eye music, there's hand music, and all of this is available at fleshmap.com if you want to peruse it in detail. But it's as I said, a more right-brained type of visualization.
And we didn't stop there. We thought, isn't it interesting how we relate to the body? What can we find out more, even, about how we relate to the body? So we decided, is there a way that we can understand how people would like to touch or be touched by lovers? And how would we visualize that? So we set out on a mission, and we decided we wanted to visualize desire. So you might think, well, how are you going to get that data? Are you going to stop people on the street and ask them, would you like to be touched here and here and here? It's going to be sort of awkward, right? But not to be scared. Internet to the rescue. What we did is we mapped hundreds of points to the body, both front and back, both on the female body and on the male body. And then we engaged the services of the Mechanical Turk, which is a service by Amazon that it's basically a market for very simple tasks done by humans as opposed to computers. And what you do is you pay people to do things for you. In this case, what we wanted was to rate parts of the body, right? And this is just a sample of how much different tasks cost on Mechanical Turk. So, to rate whether items are different, you might want to pay a person a penny. Image tagging is a little bit more expensive, so 5 cents. Answer questions and categorize, that's on the expensive side, so 10 cents and so forth. So we decided our price, and we decided we had a very interesting little task for people. So we're like, okay, we're not going to pay too much because you're going to have fun with this. And we ended up working with Doris Labs. It's a startup that basically does services with the Mechanical Turk. And we created an entire interface for rating the body. So basically, you would be prompted by different points at the body, and you would have your Apple index there of how much you wanted to touch or be touched. And then we collected all these answers. We actually had hundreds of people in a couple of days rating the hell out of this thing. And then we decided to visualize. So let me show you what the visualization actually looks like. So this is one of the ways in which you can visualize the results. So you can compare the places where people felt more intensely that they either wanted to be touched or touched. So these are obviously places where women would like to be touched versus where men would like to be touched. But then we can actually start doing some interesting things. I can actually go to the back of the woman. And on the left, I have where women would like to be touched. And on the right, I have where their lovers would like to touch them. And you can see that there is quite a lot of overlap. It's great, except that there are some really interesting little areas. For instance, the back of the neck is a lot more popular by the receivers than it is by the givers. All right, so people pay attention. The feet were a big surprise to us. We were like, oh, where are the fetishes? And but apparently we missed them. They are not very much. Our people were not very much into the feet at all, and neither were their lovers. You can get a sense for men. The same thing, the desire to be touched on the left versus the desire to touch. And you can get a sense that here the situation seems to be reversed. Lovers really like to touch the back of the neck, but not so much appreciated here. So it's just interesting to play with this in different ways. And there is also a different way in which we decided to visualize the same results.
Yeah, if you want to, you can create a kind of cartogram out of these things, where you can start out with the body itself and say, well, let's increase in size the areas where people want to touch or be touched. Or you can simply sort them. And in fact, there you see the back of the neck coming out number one in the grand list of which parts of the body want to be, where women want to be touched, as opposed to you change it to where their lovers want to touch them, you get a completely different one. So that is one whole set of artwork. We'd like to end by talking about some of our recent projects to visualize color and the way color is used. And so let's go back to our slides here. And we'll talk about a piece that we did for Wired magazine. So Wired, for its 15th anniversary, was very interested in having a piece that kind of visualized its history. And they gave us actually a fair amount of sort of free rein of what we would do. And so we thought, okay, what does Wired say to us? And it's a great magazine in a lot of ways, but one thing that just jumps out at you is those crazy covers, in particular the colors. So we thought, is there some way that we could visualize the colors of these things overall? And we came up with an algorithm that looks at an image and extracts sort of the key distinctive colors in an image. And then we can draw those in various ways. So in this case, what we decided to do is to draw these as a set of concentric circles. So for example, this image on the left, sort of the central color is orange. So that gets a very thick band. There's also a little bit of yellow. You can see that in a band around the end. And some black, which is in the center. And similarly, you can see these other covers give you can be condensed into this color-only view that takes away the shape and leaves you just with sort of the feeling. What does that look like when you do this en masse? Well, you can take all the covers at once. So this is a view of just the covers themselves. This is actually a little bit, it's almost like a calendar in a way, but the rows are each row is a year, and each column is a month. So the central rows are going from January to December. You can see the very first row is early on in its history when it was bi-monthly. And then we can convert that into colors, and we get this poster that ultimately resulted. And it gives you sort of a sense of the color evolution of Wired. The size of the circles in this case also reflect the circulation. And you can start to see interesting patterns or sort of quirks of the art directors. So January is the column most to the left. You can see is very, very simple. Like there's something they liked about starting a new year completely fresh. Often it was just completely white, or even if not white, almost monochromatic. So this was a way of using this color extraction process to get at a sense of color evolving over time.
And so we got very excited about the fact that we could work with color and try to explore what are different ways that we can work more freely with this notion of color and how it surrounds us. So a little bit later, after we did this piece, we got commissioned by Boston magazine. They came to us and they wanted a visualization of Boston. They're like, you guys can do whatever, but it has to be a visualization of the city of Boston. So we thought, okay, one of the cool things about Boston is it's you know, it goes through beautiful seasons. The seasons are really marked here, so is there a way that we can capture that? And obviously, seasons have everything to do with color, right? So how can we capture that? We decided to go in Flickr and scrape all of the photographs that people had uploaded to Flickr that were public and under a Creative Commons license, and that were tagged Boston Common, because we felt that would be a great place to try to see the change of seasons over time. And so we just scraped all of those photos and then decided to sort of squeeze out all the colors in all of the photographs, and then create sort of a calendar of this over 1 year. So we did this for the year 2008 of all the photographs that were taken and tagged Boston Common. And this is what we ended up with. So basically what we're doing here is we're going month by month in sort of like clockwork direction. And you can, you can see things like on the left here, the bulging whites and grays of winter, right? At the top right, you get this really nice little band of very striking magenta, and those are the flowers in the park that are coming out on spring. You also right there get a bulging green for the summer. And at the bottom, sort of towards the bottom left, you start to get some of the fall foliage, okay? In fact, one of the things, you're seeing this as a continuum. This is what it ended up looking like on the magazine, where they were demarcating the different months and actually calling out some of the photos that actually made the visualization. And then one of the interesting things is that you can start partitioning things into the seasons, and you can get a sense of how different they actually are in terms of a color palette and sort of the ebb and flow of the seasons over time.
So this is creating images by looking at repetition across a bunch of photos. But what if we look at just single photos again? So this led us to a project we call Luscious. And we're both kind of fascinated by the beautiful ads that run in fashion magazines or other magazines for various expensively produced ads for expensive brands. And we wanted to somehow visualize the colors of these, visualize the palettes of these in a way that also erased some of the underlying content. So to do this, we created this visualization. It's sort of a cross between the two you just saw, where we'll take an image, like this image of the pear at the left, and then we'll create an arrangement of circles that comes close to kind of tiling the image. And within each circle, we apply that method from the Wired magazine cover, where we pick out the key colors and then just draw those. And it gives you a way of getting a sense of these palettes, yet erasing the content. And so let's just show you how some...
So one of the interesting things about this is that if you look at the photograph by itself, you might say, oh, okay, so this is great. This is, a big pear in the middle, inside a brown bowl, right? And because our eyes are so good at understanding color contextually, you might think this is a brown bowl. It's great. But when you look at the colors by themselves, look at how much blue there is in that brown bowl, right? The reflection actually is not just lighter brown, it's actually blue. On the top there, you can see the difference in a bunch of lighter greens and how they play off from the background. So the fact that there are all these plays on the palettes of the photographs, and that our eyes are so good at parsing out, the color of objects, a lot of times are not even aware that, a reflection might have a completely different hue than the object that is reflecting light of. And so what this sort of technique allows you to do is to, like Martin was saying, decompose, sort of abstract away from the fact that we're looking at objects and really sort of getting at why some of these photographs are doing such a beautiful job with their colors and how balanced they are.
Here's a Valentino ad and what it turned into in the process. Here we see Absolute. This is a camel ad. I think it's sort of much more beautiful than the original ad. Proved it. And let's see, Fendi. Oil of Olay is actually remarkably subtle, I think, once you apply this process to it. I think we'll end there. And hopefully, if nothing else, we've convinced you of the power of sort of simple repetition, whether it's looking at repeated text, repeated colors, people repeatedly rating things on a mechanical Turk, to get at some of the underlying truth about data. Thank you.
Would you like to take questions?
Sure, are there questions?
To get at the underlying truth of data, that's wonderful, and what you've shown is very creative and artistic. I wondered if you'd just speculate a little about how things will develop in the future such that there'll be more kind of procedures and directions about how to apply visualizations to a data set rather than just start from scratch and worry about the mapping, worry about the technique. There's so many types of visual. Do you see that happening, or do you see this continuing to be such a creative process?
So I think there's no easy answer to that. I think even for experts, deciding on what technique, what best technique to use within a data set is as much art as it is science. Having said that, if you have, sort of simple data sets, yes, I think that there are already very good guidelines out there to sort of guide you through, if you have a hierarchical data set, there are different kinds of techniques that you should use for that kind of hierarchical data. And some software is starting to do that. So places like Tableau actually try to suggest to you, oh, given the data set you have, here are a few suggestions of techniques you might want to try. A different approach is what we did with Many Eyes, where we were really interested in just sort of taking away all the barriers and not worrying. Even if you make a mistake, it's okay. The idea is to get people to start interacting with the data in the first place and start trying to do these things. And what we saw on Many Eyes is that, yes, a lot of times people would make all sorts of weird mistakes about the way they were trying to map the data to these graphs. But a lot of times we actually interviewed a lot of our users, and we found out that they were really good at looking at what other people were doing successfully and trying to learn from them. So what was happening in a place like Many Eyes was a lot of sort of social navigation where they were trying to learn just by example. The other thing we had, obviously, was what we hoped were very short and to the point explanations about how each technique could match your data given a specific data set.
Yes.
Yeah. Are you going to move into possibly creating physically sculptural objects based on the technique, say by machining plexiglass or metals?
I think we would both love to work on projects of that nature. I don't know that we have very specific plans, but actually it's something that we've occasionally sketched out ideas on, creating sort of physical objects, even mobiles that are based on data. I think it's a great area. So anyone who wants to work on that with us, let us know.
Do you do like all of your own programming or which languages do you use, or how do you implement? I mean, there's getting the idea and then there's actually implementing it. So how do you go about implementing it?
So we used to be a very Java-focused shop, so yeah, we implement everything. So Many Eyes, for instance, is mostly done in Java, all the visualization pieces of it. And now we're starting to try to move away from that a little bit, try new things with JavaScript. We're trying to push the boundaries and understand what JavaScript can and can't do. We tried a little bit of Flash, but not too much. But I think JavaScript is going to be our next exploration in terms of languages that we use.
Yes.
So you've left IBM and now you're forming your own company. Can you tell us a little bit about what you plan to do there?
Sure. So our focus there is on visualizations that are aimed at consumers and mass audiences. We're very interested in, any way of sort of presenting data to a lot of people and aiming sort of almost, you know, in the way that a media company might do that, or another company that just wanted to engage people on the web. We're offering consulting services, so we offer everything ranging from strategy, just talking to people about, okay, you have data, you might want to visualize it, use visualization for some reason. We can help you sort of focus a question from, you know, sort of a desire to use visualization to how it could be used and how it could advance the business. Talk about design, so actually coming up with very specific, you know, mock-ups of exactly how a visualization could look and the interaction could work. We're also able to help with development.
Well, as part of your last answer, you used the phrase "on the web," and I was wondering if you're trying to get data visualization out to the masses, whether you're considering iPhone and Android apps.
Yeah,
Yeah.
actually,
Yeah.
yes.
Absolutely, yeah.
I think what you showed here is very interesting in terms of the visualization. What I see is visualization provides people with a fresh perspective of culture or pattern of human mind. What I wonder is, have you thought about to give some kind of practical use of visualization? For instance, use visualization to predict what's going to occur. Use the past pattern to predict what's going to occur. I remember there was some talk a few years ago about using newspaper articles, the words there, to the way they report disasters or terrorist incidents to predict when the next incident, I mean, not to be exact, but to make it to be useful to help us to, in a different domain instead of just a fresh perspective of understanding human civilization.
So I think there are two answers to that. One is that what we showed here, some of it was art towards the end, but in the beginning there were a lot of things that even though they were not predicting the future, they were very, very practical. So a lot of people were using visualizations, some of the visualizations we showed here to understand things like, is there a crime wave in my town? Or is it just, are people just talking about it without knowing the facts? How can I act on things like corruption? So there are a lot of things that people are already doing with visualizations that look at data that we already have right now. I think the other part to the answer is what you're asking in terms of prediction. And that's a great point in the sense that, yes, some of the things that are starting to get out there are starting to allow users to sort of model things. So for instance, one of the things that I always like to refer to is the New York Times came out with this really cool little calculator of whether it would make more sense for you to buy or to rent a house. And this was a visualization. And you could input your little data and say, I'm willing to pay this much, put this much down payment, or I'm willing to have this much payment on a mortgage. Is it better for me to rent or to buy? And where do I live? And it would calculate this for you and show you the curve of whether you were above the sort of cutoff line for buying or renting. And that's an interesting way of giving people a very practical way in which to sort of put themselves into that picture and seeing how their own situation relates to this much broader national picture. So yeah, this is a great use of visualization.
We should probably wrap it up
Okay.
after the next question.
All right, one more question, and then you can talk to us later.
Well, it's an open-ended question because there's opportunity now. We're talking about basically adding understandability, but in a fun way, and in a way that, for example, when I was at Cooper Union, we had lots, and there's art schools all over the university that have some of the curricula up in some of these very creative think tank ideas to structure to start. And opendata.gov is looking for, data.gov/open. So the CIO, Chief Information Officer, was speaking at MIT a couple weeks ago, and so she was speaking 2-hour session, twice as fast as me, and got a lot of stuff in, and was very excited to have computer scientists and there to all ask for these kind of fun tools from looking, their mission was to put out the raw data, and they have done a lot of that in this last year, a lot of it. And so then how to parse it, just like you're saying, for value added, that's also fun or humorous and shows the difference. This is a huge one where you had the stacks to show that if something was happening in the news a lot, but statistically, you're ignoring the 99.9% of stuff that's good. So it can show in a blocky way or very, very quick visualization of really compared to the majority of stuff, and especially when you put in an example of something else, like, kids winning, getting involved in community testing of the river waters or something like that. So she's saying, just come on down to data.gov and /open, and I encourage you to do so when you see something as inspiring as this.
Yeah, I wholeheartedly endorse that. Thank you very much.
Thank you.